Hello everyone, my presentation is about 3D user interface technology. As we can see in this video, the ultimate ideal 3D user interface technology can help us to finish every action via spatial devices, such as move, delete, pick up any item from the whole structure or entire body. After watching the ideal model, let's see the current education issue. In our real classroom, especially in China, the large population of students crowded in a limited space with classic traditional learning method, especially for the students in medical major, they don't have much practice thanks to teaching resources. Now, let's see what features of 3D user interface technology can solve the education issues. Firstly, 3D interface can improve students' understanding of the course content with spatial visual effect. Secondly, 3D interface supports collaborate control to make students more engaging. Thirdly, free space feature can expand the outreach to more students in every corner of the classroom. Now, let's see how 3D interface technology works in education. The next 3D interface technology test video is brought to you by Microsoft GSpeak. GSpeak is a spatial operating environment, a new computer platform. As we can see now, users use their gesture to send comments to computer. When we use the technology in the classroom, teacher can point everywhere and show the zoom up, zoom in pictures and examples to students with an amazing effect. Teachers and students use this interface to interact with computer screen. Teachers can use a big screen as a blackboard and students can use the tablet screen as a notebook. GSpeak programs execute in real space, direct interaction with the room's computers and screens. User may move the contents from one piece of screen to another. Teacher can send partial or whole contents to students' tablet devices and students can submit directly to teacher's blackboard. Teacher also can move his contents to every corner of the classroom to ensure all the students can see clearly to improve the understanding and learning efficiency. Spatial interaction allow for collaborative control. Students may collaborate with each other to control the screen. They may control to finish the project and class assignment together easier. Although the direct manipulation provides the handways access to the information, the users can use their hands gesture to send all the orders to the computer. It's very accuracy and very simple. The platform is optimized for mass data size and time-critical work. This feature is very good for the cloud database teaching and learning model and very useful for the science students to create their works and to explore all the works they created. After watching the GSpeak test, let's see what development in 3D interface ideal model field. The ideal interface model needs two aspects. First one is the hand and gesture spatial tracking system. Second one is the 3D visual effect in the space. Some smart people have already got the gesture spatial tracking technology. he used in his video just the simple stuff in his home to achieve the hand spatial tracking and let the computer record his gesture to accomplish the spatial hand's outer goal. Now, let's let him to illustrate how he do this.
Parts for this build. You will also need these tools. Start with 3 cardboard squares about 12 inches square. Attach 3 similar sized pieces of aluminum foil to one side of each square with spray glue or glue stick. Work slowly and make sure to leave a small gap around the edge of the foil. It is important that the foil plates do not touch each other when we tape the 3 sides together. Using tape, assemble the plates to form 1/2 of a cube. Next, we need to prepare the wiring. It is important to use shielded wiring so that the cable itself doesn't act as an antenna and skew your sensor readings. Cut the wire into 3 2-foot lengths. Strip off the outer and inner insulation. On one end, trim the shielding wire and connect just the inner signal wire to an alligator clip. Repeat for each length of wire. On the other non-alligator clipped end of the cables, twist the 3 shield wires and solder them together. The shield will be connected to the 5-volt pin on the Arduino, which will minimize the antenna effect of the cable on the circuit. As shown in this schematic, each plate connects to an Arduino pin through a 10K resistor. In addition, each plate will have a 220K pull-up resistor. In turn, each plate will be charged and then discharged through these resistors. Twist connect a 10K resistor to the inner signal wire of each cable as shown. Then twist connect a 220K resistor to each signal wire and solder both resistors to each wire. Twist and then solder the 3 220K resistors together, then solder a piece of jumper wire from the shield wire to these resistors. Then add a second jumper wire from this junction. The wires are now ready to connect to the Arduino. Connect the 3 10K resistors to pins 8, 9, and 10. Connect the jumper wire to the 5-volt pin on the Arduino. Attach each of the alligator clips to a foil plate. The clips should be attached in the following order: pin 8 to the left or X plate, pin 9 to the bottom or Y plate, and pin 10 to the right or Z plate. Make sure that each clip is making good electrical contact with the foil and is only touching one plate. Now the sensor cube is ready, and all you need to do is upload the Arduino sketch. Download the Arduino and processing sketches from the how-to on Make projects. You'll also need the processing and Arduino development environments, which can be downloaded from their respective websites. From the Arduino IDE, upload the sketch to the Arduino. Keep the USB cable connected to the Arduino, then install and load the processing sketch. Now everything should be set. As you move your hand around inside the cube, the sphere should follow your movement. This project shows you one way you can use a microcontroller to turn very simple materials into capacitive sensors. The same techniques can be used to make your own touchscreens or turn pennies into switches. Try it, and you'll see how a simple idea can yield surprising results.
For the 3D visual effect, Microsoft already developed it in its Xbox game. The name of Illuminate-Room is the project that Microsoft can develop a 3D visual effect without wearing 3D glasses. Okay, from all the presentation I have made, we can see the ideal 3D user interface technology can bring a revolution in our traditional education. As the movie Iron Man, we can see how the 3D interface can bring us the convenience life. Okay, let's enjoy the rest of the presentation with Iron Man's technology, and thank you for all your attention.